Yes, you know what time it is. It's time for Reconstructing the World. My name is Anders Morgenthaler. I'm the host of this program where we discover new material to work with, sustainable agenda overall. Unfortunately today, my co-host, most sustainable architect in the world, Anders Lendager, couldn't be here because he met Damien Hirst over the weekend. That was a great joke.
No, it's actually my post fighting the fossil fuel industry.
Yes, I like that joke actually, but I was too seriously obtaining that information. Anders, most sustainable architect in the world. It's a joke to you who has no irony at all, but you are. Okay, today we're going to talk about
Windows.
Windows!
They're everywhere.
Yeah, not the program, but the window in the building.
Ah,
yes.
probably.
And let's start to talk about the window's role in modern architecture. In modern architecture. Thank you.
That's a good cue.
Yes.
So, windows, especially in high-rise buildings, has been playing since the modernism a really, really serious role. Basically, they've been built out of steel. Yeah. They've been built out of concrete, and then they've been built out of a lot of glass.
Yeah,
basically only glass.
Modern buildings.
Modern buildings.
A lot of concrete inside, a lot of steel outside with window frames. We know it all, right? Like this, actually, where you have the whole facade in a building built like this.
Exactly.
Yeah.
And so there is, of course, some things that are really important with windows is that we get daylight in, and we get a beautiful view. And the higher the building is, the more beautiful the view.
Look, a beautiful view.
So, and the problem is that producing glass and windows is emitting a lot of CO2.
Yeah.
We are normally using aluminum framing.
Yeah.
So all the framing of windows are normally massive aluminum.
Okay.
And they're called curtain wall facades because it's basically the whole facade.
Actually, like you have elements up there, right? That would be.
It looks.
And then inside also.
It looks like a curtain wall, but it's not. That is what we call in Danish a put i hul window. So it's a window put in a hole.
A put in hole window.
Put in hole windows.
Okay.
And that's normal windows, and that's what we have here. So what you see here, even though it's a very huge window, it's just a normal window put in a hole next to the next window here. You can actually look through here. So what is interesting in this building is that we, of course, have some massive walls with smaller windows in that is actually quite big. And the places where we wanted to have the best spectacular view, we have these very large windows partitions.
Okay.
And
what is the reason behind that? Why did you want to move away from traditional
curtain wall?
Normally this would be all windows in most high rises, right?
Especially the more classical buildings.
Yeah.
Today we are not allowed to make just a glass building.
Okay.
But there's a lot of buildings you think is a glass building, but it's actually not. Okay. So you just have glass in front of some insulation, but you're using glass as a facade.
Okay.
But glass is highly CO2. It's using a lot of CO2 in the manufacturing.
Yeah.
And now we have a crane.
Let's go over here
to play with us as well.
Let's move away from the crane.
What?
Over here.
The interesting part here is that all the framing of the windows are wood. So we have minimized the use of aluminum and steel a lot.
Okay.
So that's an important step for this building in the process of using more sustainable material is to go away from steel and aluminum.
So actually just by cutting down on the amount of aluminum, that's a huge that's a huge displacement reduction.
Yes. So of course the glass is the highest emitter of CO2.
Yeah.
But the framing also has a crucial role in that calculation. And here in our LCA calculation, we calculated with half of the framing being aluminum, which is not true. It's way less. It's only kind of the outside of it,
Yeah, like
the clamps,
you can just see the. We'll see a cut on the window over here.
and the rest is actually wood here. So one thing we are working on, and we are going to have that, it's only 100 square meters or 200 square meters, I can't remember. We're going to come back on that.
We'll put the correct number on the screen.
Which is in the ground floor. And that is actually where we're using discarded windows from the industry. Because what happens often is that you misproduce these facade windows, which means that if this one is just 1 centimeters too wide, it's waste. And these are just crushed and become recycled glass that needs to be remelted and so on. That's really bad.
I can't handle the truth.
The truth is
I can't handle it, Anders.
But you have to. You heard much worse things.
No, seriously, every time we talk about...
And there is a Danish manufacturer of glass windows.
Yeah. Who?
Could be roof windows. It could be something like that. They have between 30 and 40,000 square meters of waste. And that's just for a pretty big manufacturer, but just in Denmark. So imagine how many windows that are discarded, that has scratches, or actually, are just thrown out because they were a little bit too big.
And
these windows.
I'm just going to pause you here, because you're just going to cut to one of your old buildings.
Yeah.
Upcycle Studios, where you built, and we'll put the pictures on now. Yeah. The pictures of all these row of houses that are built around discarded windows. Yes. Meaning that actually they, the whole project is formed about around reusability of recycling of windows, right?
Yes, exactly. Yeah. But in that project, the thermal windows are actually old windows, like really old windows that's been sitting in a building. Here I'm talking about that we are actually using new windows from the industry that just doesn't fit the purpose for a project, and then they're waste.
Are these?
Not these, but I'm going to show it in the ground floor. Okay. And we hoped to do that in the whole building, and we were planning for it. But wait, you're going in front of the camera.
Yeah, I wanted
to. But unfortunately, because of energy calculations, just a comma here and there, the calculation said we were not allowed to use these windows everywhere in the building. Instead, we're producing all these new windows, and we could have done it everywhere in the building. And it's a really interesting question. Do we use our energy in producing new products, or do we use our discarded waste windows?
So what you're saying is, if regulation could have managed to do an
energy calculation,
an exception.
You're on a
they could have said, okay, you can discard. You can use the discarded windows, even though you have 1.0 whatever.
Yes.
Okay.
And what the engineers is afraid of is that it's not only about heat loss from inside to the outside, but it's also about too much heat coming from the outside and in. From that bridge you see there. Yeah. Can you see that with the camera? There's a bridge, right?
I think the hole here is bigger, so we might see the bridge a little.
So this is an old coal crane track. So that's going to be refurbished. We actually won that competition long time ago.
7 years ago or something.
Yeah, a million years ago.
Not a million years.
And I don't know if we are even going to do it, but I hope so. Right. But then you're going to be able to walk on the bridge to there. And from there we are building, we call it the walking snake.
Oh yeah, between here.
So you can walk through here. And there's going to be a cafe hanging in there.
Also nerdy when you nearly tripped.
So you like that?
Yeah, I like when you're nerd. I like it when you're nerd.
And then it goes around here.
So it's gonna over here. Come on. They're gonna walk out here.
They're gonna walk here, and then come around here.
Yeah. Inside here.
Exactly here. This is going to be a wine cafe, whatever. Something.
No shit.
There's going to be a terrace hanging out here where the bridge passes over there. And then it goes down and hits the road down there. So it kind of have a slope. That's why it's a cool view. But we're going to see that later.
There's going to be a wine bar here?
Yes. And a terrace here.
When you can walk to the city?
Yes. That's cool, right?
I'm going to grab your dick. You have a big uterus, man. So, not only did you minimize the aluminum, you could have minimized the glass, use of glass.
Yeah,
And I was just checking out the window here.
yes,
The amount of aluminum used,
it's only this.
it's like really
Yes.
really thin.
And it's almost nothing, but it's calculated as half of it. And we have to come back to that in the life cycle assessment. We can show it in a diagram how these are calculated, but it's just really interesting.
Yeah.
And it's just, this is a beautiful window, and this is new aluminum, just to say, on the front.
Yeah.
But on the small windows, these ones,
Yeah.
maybe we can see that.
Yeah,
with
let's go to a small window.
Jeff, cameraman? Camera guy. What is it called? Not cameraman.
I love that you call him
Sorry.
camera guy. It's called a cinematographer.
Cinematographer.
Yeah.
That's why he's always so mad at me. Good guy. Can you see these?
Can you see those?
This is actually waste aluminum from
the outside.
The outside.
Ah.
There was supposed to be mailboxes, but the mailboxes manufacturer
for letters.
didn't like that there was water on the aluminum before they manufactured them, so they discarded 13 tons of aluminum.
And then,
And
you
these
said, and then
sheets-
you said,
And then we said yes.
hey, I'm the most sustainable architect in the world.
Yeah,
Can
and then
I
we-
buy that?
And we got them super cheap. And now they're way higher quality than what we normally get to do that.
Normally I wouldn't say it, but yeah, so, a crane did something there. It looks like shit. I'm just saying.
Anders?
Why? Look at that.
Yeah.
Why is
Yeah.
it like that, Anders? Most sustainable architect in the
That
world.
is.
Also there.
Oh, shut
Oh
up.
my Jesus Christ!
But over here, we should have picked
It's
this one.
the wrong window. That's going
This
to be
one
fixed.
is way better. Forget about that window. This is a way better window to show something beautiful about the discarded aluminum.
And look over there. 1, 2, 3, 4, 5, 6. It's going to be as a fantastic, right?
A very short moment. I thought you were going to count them all.
There's 2 more there.
No,
You see them?
Please stop. Asperger's. No,
I think.
a little too much. So, and then all this.
But I'm not finished.
This,
Yes, I'm not finished with the windows. Should we?
so,
But the cool thing is that inside the building, an office building, there's meeting rooms.
Yeah.
And there is just as much glass in the inside of an office building as there is on the outside.
Yeah.
And that's the easiest glass actually to recycle. So right now, we hope it's going to be in the whole building that all glass meeting rooms is going to be old thermal windows from old housing
like
units.
in all the windows there, with all the glass walls.
Exactly. But
So
right now we know it's in all kind of the larger meeting rooms in the in the cantina and in the meeting floors and so on. And we hope that it will be on like all floors. But they are more expensive. We talk about economy, and these are a bit more expensive.
Okay.
But they are super cool, made out of waste wood and old thermal windows. And that makes so much sense to harvest old windows that are perfectly fine as thermal windows and put them inside in the building. What's not to like?
So, and this is one of your trademarks, right? That you recycle windows.
Yes.
Yeah.
This is from Easy Rider.
No, but one other thing about you minimizing the amount of windows and all that is also it has a huge effect on the AC bill, the economy of the cooling and the warming of the building, right?
Yes, it does. I mean, that's the whole point, that windows and calculation of the quality of windows is the equivalent of use of energy of heating or cooling the building. And that's a super big discussion. And that's what I said. You know, if you go down in quality on the windows, then it might be that the building gets warmer.
Yeah.
But how much warmer, and how, could you solve it by opening a window?
Yeah.
Could you solve it by, doing something else, having thermal mass? Concrete has one good thing about concrete is thermal mass.
It's good at retracting heat.
Yes, exactly.
Holding on heat, right?
Yes. And but I really think that
I love that window. Most sustainable architect in the world. Why did you put a giant wood piece in front of the window?
that
Seems kind of stupid.
that is.
Imagine I'm being a kid. Oh, mommy! Oh, I'm stuck I can't, whatever, I can't get ever.
Most ridiculous host in the world is stuck in a beam. Normally you are wood hogging it.
This was more of a death trap situation.
The reason why is that we wanted so much to show from the outside that it's a wood building. So we on purpose let the windows sit in front of the main structure instead of pushing it away, because we get aluminum cladding or recycled aluminum on the facades, but we want to show that it's a wood building. So that's why it's in front of the windows some places.
That's real architecture smooching right there. I've loved to have been a fly on the wall, like, okay, what I imagine is that people all over the world will go by, glance at the window and say, hey, it's a wood building in there. Ooh, ooh, ooh. That's what you imagine, right?
Exactly.
I know.
Yes, that was exactly what happened.
Is that a course you take in architect school?
Yeah, it's
called the bullshitting of developers.
Yeah, it's around 5 years of education.
Yeah, it's like you have to wear a turtleneck every day.
Turtleneck,
okay.
and glasses.
Okay. So
you have to have Moscot glasses on.
Okay.
To bullshit.
My is Moscot actually. So, but anyway.
What? Did you go there?
No. So we have established that this is doing a lot for the sustainability of the house, the minimizing, the whatever. So let's talk economy. We always finish with economy, honest.
Yeah.
What is the economy of this shit? Windows, sorry.
The economy of the windows. I think that in this case it's a cost neutral product.
Ooh.
Because the windows, the glass pieces are really, really big, and they're not sustainable in the manufacturing of these big sheets, and that would have been the same for a normal facade.
Okay.
But where we are saving CO2 and are doing something meaningful is to make this out of wood pieces. And
so all this
so Krone is our manufacturer, a Danish manufacturer of windows, and they've done these beautiful wood windows, and they're of course not super cheap, but it's also an expensive component of a building.
And the wood.
So it's expected to have a that they're expensive.
Is it waste wood?
This is not waste wood.
Okay, so this is new wood because
it's new wood.
It's too dangerous to play around with the waste wood because you don't know if it's gonna fall out or fall apart.
These are a pretty complex component, and from guarantee and so on. In this case, in this size, exactly here, this was new wood and new glass. But
as we have talked about in earlier episodes or in future episodes, I don't know the whole interior of the building wood here is based on waste wood. So meaning that is room for working with new wood here, and especially reusing windows also.
We save the upcycled windows that we are doing on the ground floor. There we are saving 87% CO2 compared to a new window.
Yeah. Oh.
So 87 on those ones down there. And that's why I'm saying the interesting discussion point here is, do you want to use a bit more energy in heating, cooling over 50 years versus the energy used on producing new windows? And that's the ongoing discussion in this. What makes the most sense when we are on very, very small decimals of windows becoming better or worse?
As we often talk about, Anders, is we have to emphasize on reconstructing the world the forward point: don't build anything. That's the most sustainable. Build with what you have.
Exactly.
That is the second most sustainable. If you need to build a new building, you should do it out of waste and out of wood. Hopefully, use the most recycled wood. And we need to talk about this all the time. And then we need to talk about the calculation, saying, okay, that if you save so much on reusing windows down there, you can move that a little around so you can have these new windows here.
Yeah.
And that should be a discussion that we can have. But the problem is, when people discuss that, it's also become very theoretically discussion. The main goal is always that, you can move stuff around, but you should always reduce.
Yes.
Is that correct?
Absolutely correct.
I'm out.
Well said.